Hello everyone, this is the third video in the Terminal course. In this video, we'll delve into text editing, viewing and text analyzing tools available in the terminal. While going through command APIs isn't as captivating as learning through real examples, we'll tackle a few real-life situations in this video where you might need these tools. Throughout the lesson, we'll read and edit a script that generates logs, monitor those logs, analyze them, and understand the associated processes. Typically, you wouldn't use the terminal to edit or read large files as it's not very convenient. Even with the various plugins that you might find or create yourself, working on a big project can be challenging, especially now when we have such sophisticated tools like VS Code or WebStorm. However, there might be situations where you connect to a remote machine without a GUI and you need to modify a few lines in a configuration file or check the logs of your service. That's our starting point for this session. I've prepared a file that will simulate a server. The only difference to a real server is that it only generates errors and logs them into a file. The file is named log generator, and to examine its contents, we can use the cat command. You might find the name cat amusing, but like many terminal commands, its name stems from its function, to concatenate and display files. It prints the contents of a file directly to standard output. You might be wondering what this has to do with concatenating. Well, if you provide the cat command with two files, it'll stitch them together. In this current directory, I have a package.json file, which we can concatenate with our log file to view them simultaneously. I don't know why, there is no point in it, but still. The cat command will display both files consequently. When you provide it with only one file, there's nothing to concatenate, so the command simply displays the file as it is. We don't need all that information right now, so let's clear the terminal using the clear command and display the content of our mock server script. While I could do this by typing cat log generator again, you can retrieve this command from your terminal's history by pressing the up arrow a few times. There it is. We won't delve into the details of this script for now. As I mentioned earlier, it's not very practical to edit scripts with terminal editing tools. However, there is one line I'd like to highlight. This one. This is where the script sources the log file variable from. Given that this file is relatively short, finding a specific line isn't a problem. But imagine if we wanted to review the readme file for this script. Let's try it with cat readme.md. The output is extensive, making it challenging to locate the section discussing environment variables. This is the perfect opportunity to introduce the less command to you. When cat immediately dumps the entire content of the file to the terminal, less displays the file's content one screen at a time. You can navigate up and down, search for buttons, and even jump to specific line numbers. It doesn't load the entire file into memory, making it efficient for viewing very large files. There are numerous shortcuts in less, but the primary one you should be aware of is H, which opens the help page. One symbol that might be unfamiliar to you is the caret, represented as this character. This symbol denotes the control key on your keyboard. As I said, I wanted to show you less to make it easier to find the details or where the environment variables are coming from. Here, under the searching heading, you can see that we can use the slash command to search forward for matching lines. Let's press Q to exit and then enter /env to find what we're looking for. Les highlighted the matching lines, and now we know, again, that the variable are coming from the .env file. We can now close Les by pressing Q. According to the readme file, there must be an .env file. Let's check it with the ls command. The command says that there are no env files at all, and that's because an env file is a so-called dot file. Dot files are hidden by default and are primarily used for configuration purposes. By default, commands like ls won't display these hidden files to reduce clutter and to prevent users from accidentally altering or deleting critical configuration files. To reveal dot files in a directory, we can use the -a option with ls. Now we can see the .env file along with the entries for the current directory and the parent directory. Given that it's a compact file, I'm sure that we can expect it using cat. What we see here is that the variable log file is set to logs.txt, implying that new logs will also be appended to that file. I prefer not to save new logs in this file since I want to keep today's logs separate from the existing content in logs.txt. To achieve this, I'll need to modify the .env file. There are multiple tools available to edit a file in terminal. Among the options are VI, Vim, Emacs, Nano and its cousins Pico and Micro. While not all of them are pre-installed in every operating systems, both VI and Nano are typically available. VI is notorious for its learning curve, but offers robust functionality, whereas Nano provides a straightforward and user-friendly editing experience. Let's use Nano to open and modify the configuration file. Covering the intricacies of editors like Nano or VI is beyond the scope of this lesson, as diving deep into them would be time-consuming and potentially tedious. However, we'll touch on the fundamental aspects. Nano is especially beginner-friendly because it starts in writing mode by default, which means you can change the file right away. That's not the case with VI, for example. Let's change the name of the logs file. You won't find the save shortcuts. Instead, Nano follows the long-standing Unix tradition where write and write out is used to save changes to a file. Thus, we need to press Ctrl O. The name of the file stays the same, so we press Enter. If you ever feel lost in Nano, press Ctrl G to see the help page with all the commands. And now we can exit by pressing Ctrl X. We're all set and ready to run a fake server. To run a shell script, which a server is, we can simply type its path into the command line. Since it's in the current folder, we can write a relative path to it, starting with a dot, meaning the current directory, following by a slash and the name of the script. If you don't remember the name of the file, type a few characters and the shell will help you complete the name, or it'll show you suggestions. Press the tab key and the name will be completed for you. Enter and it might seem like the program isn't doing anything. In fact, the program does not display anything in the standard output. The outcomes of its operations can be found in the log file. Let's open a new tab by pressing Command T or Ctrl Alt T on Linux to view the log file. If we check on the file with the cat command, we'll see the logs. Thus, the server is working fine. However, in day-to-day development, you won't typically inspect logs statically. You might want to either analyze them or monitor them in real time. Let's focus on the latter. To do this, we can use the tail command with the -f option. This command will display the logs as they're written to the file. As you might have guessed, the tail command shows the most recent parts of a file. Let's explore how it functions. First, we need to stop tail. On both Linux and Mac, this can be done by pressing Ctrl C. A few seconds have passed since we terminated the process, so there should be new entries in the log file. We can inspect these by using this command. The N option specifies the number of lines to display. Naturally, if there is a tail command, there's also a head command. Executing the head command with the same flags and arguments will display the first 5 lines of the file. Now let's discuss the analytical aspect of working with logs. Mastering this skill can take a significant amount of time, so we'll only touch upon it here, with the possibility of delving deeper in future videos. WC is one of those commands that should always be within reach. The name stands for word, line, character, and byte count. The default action is equivalent to specifying the L, W, and C options. When we run WC on our file, we find how many lines, words, and bytes there are. Typically, you'd use the WC command in combination with other utilities such as grep. For instance, if we want to determine the number of errors in the file, we can execute the following command. Another option would be to find how many info entries we have. To do it, we can simply replace the word error with info in the command. However, our brief introduction to grep only scratched the surface. Grep is an incredibly powerful tool with a rich array of options that allow for complex pattern searching and manipulation within files. We'll be diving deeper into grep and its many uses in another video. For now though, let's head to the previous tab and stop the server by pressing Ctrl C. Using Ctrl C to stop the server, we've touched on the topic of process management. Process management isn't just about starting and stopping tasks, it's about understanding and controlling what's running on your system. In the next video, we'll cover how processes operate, ways to locate and manage them, and how to handle tasks in the background and foreground. Understanding these basics can make your work in the terminal smoother. Thanks for watching today. Join me in the next video where we'll dive deeper into process management, and see you next time.